Our third concept is going to be net present value. So when we consider everything from FDI, should we take on a project, if we're debating whether or not it's going to be worthwhile to hedge, if we have some risk, all of it, we're always trying to assess what's the net present value of this decision. So how do we solve for our net present value? On our left-hand side, we've got NPV subscript 0. Remember, whenever we see one of those subscripts, it's telling us the time subscript. So that's important. Our net present value today at time 0, it's going to equal what? Our cash flow at time 0 plus the expected cash flows for periods 1, 2, 3, all the way up, each discounted back to today. So why do we have expected cash flow? We have expected cash flow because oftentimes we're not certain what the cash flows will be. We'll have to take an expectation of what we think the cash flows could be, and we'll do an example of that together. The other thing that I want to point out is our cash flow at time 0. Notice how it has no discount rate. Why? Because it's our cash flow today. Typically we're going to have to pay some money for a project. We're going to have to pay some money to build a plant or pay some money to launch a new business or to launch a new strategy. So we have a negative cash flow today. And then our hope is that when we sum up our cash flows and discount them back to today's dollar, that our NPV is positive. So one of the challenges will be determining the correct discount rate R. That discount rate is going to reflect the riskiness of the project, and we'll go into that more in depth in our following lecture. So another challenge is going to be to find the expected cash flow. So whenever we have an investment, typically our investment decision rule will be based on NPV. As you know, if the NPV of a project is positive, then you should invest in the project. If there's uncertainty in the cash flows, meaning that we're not certain what those cash flows will be, we'll take an expectation. So what is an expectation? An expectation is an average. So we'll take an average. Okay. A firm is considering an investment that will generate cash flows for the next 2 years. These cash flows depend on whether the market conditions are good or bad in each year. So if it's a good market, you can see in year 1, it's going to have a cash flow of 20M. If it's bad, it's going to have a cash flow of negative 15M. In year 2, if it's a good market, it's going to have a cash flow of 30M. If it's bad, it's going to have a cash flow of negative 10M. Assume that the project's cost of capital is 15% and that the project costs 15M. So the first cash flow I'm going to have to spend is negative 15M. In each year, a good market or a bad market is equally likely, meaning because we have 2 market conditions, it's a 50-50 toss-up. If we had 3 market conditions, it would be a third, a third, a third. If we had 4 market conditions, it would be a quarter, a quarter, a quarter, and so on. So in this example, the market conditions are equally likely. We'll do plenty of examples where the market conditions are not equally likely. So let's solve it out. If the project is undertaken, what are the expected cash flows in year 0, 1, and 2? So our expected cash flows are going to be the averages across good times and bad times for each of those years. So you can see our cash flow at time 1, we take an average, the 20 plus the 15, we divide it by 2. For time 2, we take an average. So half the time it's going to be 30, half the time it's going to be negative 10. We take the average and we get 10M. What is the NPV of the project, and should the project be undertaken? So the NPV at time 0 today, it equals negative 15M plus that 2.5, the expected cash flow discounted by 1.15, plus that 10M, the expected cash flow in year 2, discounted by 1.15. What do we find? We find that the NPV of the project is negative 5.26M. Should you undertake this project? Should you spend 15 million today to have a present value of negative 5.26 M? No, you shouldn't, because the NPV of this project is negative. So you should not undertake this project if you are a responsible manager. Okay. So our final concept is going to be amortization, which is paying back a loan. So in this example, we can think of amortization as basically kind of showing us a schedule of how we're going to be paying off a debt. And the cool thing about looking at amortization is that we can see how our payments are going to pay off some interest and pay off some principal. So let's do it step by step, and this will be our last lesson. So you take a loan for $1,000 with a 10% annual rate. You'll pay it back over 3 years with 3 equal payments. Step 1, we're going to make a timeline. Step 2, we're going to solve for the payments. We're going to apply the annuity formula. And then our final step will be to construct an amortization table so we can see how our loan is going to be paid off. Now, before we jump right in, let's make sure we understand why we can apply the annuity formula. We've got a loan for $1,000. We've got an annual rate, a discount rate that's going to be constant, which is 10%. And we know our N. We know that over 3 years, we want to pay this back. So we've got all the stuff that we need for our annuity formula. The only thing we don't know is C, which is going to be the payment that we're solving for. So let's look at this. Today at time 0, we've got a cash flow of negative 1,000. That's the loan that comes in. At time 1, we've got a payment. Time 2, we've got a payment. Time 3, we've got a payment. We've got a discount rate of 10%. This looks so similar to our annuity formula, where our payment is going to be C, our cash that we're paying every single year. So let's see what goes where. The present value was 1,000. This is how much we got today for our loan. C, the cash flow, is how much we'll pay each period. R is 10%. That's the interest on our loan. And N is 3. We'll be making one payment each year for 3 years. So when we plug it in, again, I can't stress this enough. We want to take our time and follow the order of operations. What do we have? We've got C divided by 0.10, our 10%, multiplied by 1 minus 1 over 1.1, all of that to the power of 3. 1 divided by 1.1 to the power of 3. When we solve that out, we've got 0.751, 1 minus 0.751, 0.249. We multiply that by our C. We bring our 10% up. We've got C times 2.49. We do the math. We bring our 2.49 over. And what do we find? We find C equal 402.11. So make sure you do it all step by step. Even though it's worked out here on the slide, pause, take the time, do it step by step to make sure that you're following the order of operations correctly and to make sure that you understand what it is that we're doing together. So what did you solve for? You solved for C, the payment that you will make for these next 3 years to pay off your $1,000 loan. So what happens? Okay, so your first payment of a little bit over 400, some of that payment goes to the principal and some of that payment goes to interest. And as you pay down the principal, smaller amounts of that payment are going to be going to interest. So this is kind of a little bit hard to see maybe graphically, but hopefully we can talk about this analytically, and then we'll set up a table to make sure that we really feel comfortable with this concept. So as you make your payments are going to go to interest and the balance. So in year 1, we've got interest of $100. Where did that come from? Well, our loan was worth 1,000. Our loan has an interest rate of 10%. So for the first year, our interest on the loan is $100. Well, what happened to that C that we solved for? Okay, we solved for the same level of payment that you will make over the next 3 years to pay off your loan. So that first year you pay 402.11. $100 of that 402 that you paid goes to interest. So 402.11 minus 100, that 300 plus what's left over, that goes to your balance. So what remains on your loan? What remains on your loan is the 1,000 minus the 302.11. So it's a little bit easier to see if we put into a table. So at the beginning of the year, our loan has a balance of $1,000 because we just took it out. We make our loan payment of 402. We have interest of $100. That's the 10% multiplied by the 1,000. Of our 402, $100 goes to interest. The remainder 302 goes to paying off the principal. So our ending balance is 100 minus the 302. So our beginning balance at the start of year 2 is 698. We make another loan payment of 402. Not all of that 402 is going to go direct to the principal. Why? Because we have interest. We take our 698, we multiply that by 10%, we have an interest payment of about 70. Of our 402, 70 goes to pay off interest. The remainder, 402 minus 70, the 332, goes to paying towards our principal. 698 minus 332, boom. We've got our ending balance of 366. Same process over again. Notice in year 3, our loan payment is bigger than our beginning balance. Why? Because we still have interest. So we take our 10%, 366 multiplied by 10, we get our $37. We pay our 402. Of that 402, 37 goes to interest, 402 minus 37. That's how we get our 366. Presto changeo, we've paid it off. We've paid back our loan and interest on the loan. So this is pretty cool. What have you learned? Hopefully you're comfortable with quite a few things. So we should be comfortable with calculating the present value of cash flows, even and uneven. Even cash flows means that the cash flow and the discount rate is the same. So we know that if we have a finite time period, meaning that our cash flow is going to be only for 20 years, 2 years, or some period that's terminal, it has a finite life, then we can very easily apply our annuity formula. If the cash flow and the discount rate are the same and the cash flows are growing at some rate, then we can apply our growing annuity formula. If our cash flows are perpetual, they're going to be going on forever and ever and ever, and the cash flow is the same and the discount rate is the same, we can apply our perpetuity formula. If we have uneven cash flows, meaning that our cash flow in year 1, in year 2, and year 3 might all be different, or if we have discount rates that are different, then we know we have to apply our present value formula and take the discount of all of those cash flows separately. So we would have our cash flow divided by 1 plus R for period 2. We would have our cash flow in period 2 divided by 1 plus R squared, and R might be different for period 1 and period 2. Okay. We should also feel very comfortable using the present value of an annuity, a perpetuity, and calculating NPV. We know for our NPV at time 0, we've got our cash flow at time 0 plus the present value of our expected cash flows for the life of the project. And the last thing that hopefully we feel more comfortable with is amortizing loans, like a loan repayment. So if this is your first time to do an amortization table, or if this is something you haven't seen in a while, again, take your time. You can pause. You can always revisit parts of the lecture. The solutions are posted. They're on Blackboard. But before you consult the solutions, work out the problems. It's okay to feel a little bit frustrated. It's okay to see that the answer you put down might be very different than the correct answer. All of that is how you learn to understand the way that I'm asking questions and the way to approach these problems. So be careful to apply the appropriate discount rate to the appropriate time period. Remember, if it's quarterly cash flows, I want to use a quarterly discount rate. If it's semi-annual cash flows, I want to use a semi-annual discount rate. Also remember that the annuity and perpetuity are the present value of payments that start next period. So they always start for T plus one. So in our examples, you always want to note that whenever we're doing annuity, perpetuity, taking our present value, these are for cash flows that happen next period. Next week, we're going to discuss the role of the balance of payments. The role of the balance of payments will be a great way for us to understand the current account. The current account is where we have national accounting of our trade and our trade in services and our trade in goods. And then we have the capital account. The capital account is where we have an accounting of all of our financial flows. Hopefully, you've read chapter one. I apologize for New York being incredibly loud and not really caring at all about my lecture. Hopefully, you've read chapter one. It provides a really good intro into the international finance, the system, some background, provides a good understanding of what a multinational is, a good understanding of foreign exchange, just a really good overview of what the course will be. And to read and prepare for next week, you should read chapter three, the balance of payments. After we establish the core concept that there's trade with our financial services and then there's trade with our actual products and goods and services. So once we understand the capital account, the current account, and the trade deficit, we can kind of use that as a great opportunity for us to understand the politics and the policy of it all and how that affects financial decisions. So it'll be a good way for us to get into some of the things that we'll be thinking about from the perspective of a firm and from the perspective of an investor. So once we establish those core concepts, we'll examine the role of the balance of payment and understanding the capital account and the current account. And then where are we headed? Our goal will be to understand a little bit more of the international financial system. So we'll look at the international monetary system. We'll talk quite a bit about Brexit, a very recent economic and political change that had very real effects on financial markets and on firms. And once we kind of lay out the rules of the game in terms of how the international financial system works, then we'll get to ask ourselves, well, what would a company do given all of these choices? So we'll start with corporate governance. It'll be a great way for us to understand agency concerns, how capital structure is being affected, basically the mix of debt and equity, how a company is going to fund itself, given that you have these agency concerns and all that stuff. So I'm excited. Hopefully this is helpful. And again, if there's any part that's unclear or any part that you feel like you don't have a good hold on, pause the video, rework the problem, make sure that you're able to find the same solution that's posted. And if you're still having difficulty or something is still not clear, email me. We can figure out using my Zoom office hours or what. So, okay, look forward to our next lecture.